Hello, pre-calculus students, and welcome to the lesson on solving exponential and logarithmic equations algebraically. And in this video and in the next series of videos, we're going to look at how do we solve equations where the exponent is either a variable or a statement in a logarithm is a variable. And the point here isn't to memorize or to really mimic, it's really to kind of learn and understand the strategies that are available to us and make a good decision. So for this one, asking us to solve for x, and the idea or the strategy that we want to take away from here is to find a common base. So first thing I'm going to do is to divide both sides by 36. So I get 1/3 x to the 5th. 4 over 36 is 1/9. Okay. And so I have two different bases right now, 1/3 and 1/9. Now there's a couple things you can do, especially if you're already familiar with logarithms. You can just take the log of both sides, and you can use your calculator. You can definitely graph. But again, the purpose of the lesson and of math in general is to help you think, to develop your thinking skills. And we want to practice this particular strategy here to find a common base. So it's kind of hard to see this. Some people might try to do 3 times 1/3, okay? But that only complicates things because you have this 3 here. So I'm going to leave the left side exactly where it is, and for the right side I'm going to convert this into 1/3 squared. 1/9 is really equal to 1/3 times 1/3, which is 1/3 squared. Okay. Then the great thing about having a common base is if the bases are the same, there's nothing else in the problem, we can set the exponents equal to each other. Okay, so we can form an equation with the exponents. So I know that x over 5 has to be equal to 2. And this is a very basic problem. Now x then is equal to 10. Once again, the idea is to be able to visualize this and see how do we get the bases to be the same. And it takes a little bit of practice, takes a lot of thinking, and to be able to be very sharp and able to see that possibility. Let's try another slightly more complicated example. So here again we're asked to solve for x. We have 3 times 4 to the x over 2 equals 96. And one thing you just really need to be careful about is this is not equal to 12 to the x over 2 because of order of operations. This is not at all equal to 12. Okay? But what we can do is divide both sides by 3. So now you get 96 over 3, which is 32. And then you look at what's the common base. Is there a way to go 4 to the x equals 32? What's x equal to? What is x going to be equal to? And this is not very entirely easy to find. Okay, so and of course you can plug into your calculator. 4 squared is 16. 4 to the 3rd is 64. Let's try 4 squared. Well, that's 16, so that's not 32. 4 to the 3rd, that's 64, so that's not 32 either. And if you have a calculator, you can test a bunch of these things. But at this time, you should be trying to solve these problems using just pure mental math. So we're going to find a simpler base. Okay, so it's still going to be common, but use an even smaller or a simpler base. So I'm going to rewrite this 4 as 2 squared and then I'm going to rewrite 32 as 2 to the 5th. And you see, now we have the same basis. Now we can work with this. So we can use the product rule here of exponents. The power rule. A power to a power, so this is 2 to the 2x over 2 equals 2 to the 5th. This exponent here, well, we can just set the exponents equal to each other now. 2x over 2 equals 5. This cancels, so x equals 5. Now, some of you may have found that 4 to the 2.5 equals 32, and that's okay if you had a calculator to help you with this, but the goal is to try and solve these without using a calculator, just so that if you ever have an exam where you're not allowed to use one, you can still do it, and more importantly, that it develops your thinking, especially your critical thinking, some of your mental math skills. So that'll help you in other areas as well. So thank you for watching this video. Have a wonderful day. Make sure you watch the next videos in the series on some other strategies to solve for exponential and logarithmic equations.